it's Fix here. Today I'm doing an oil change on my 1995 Ford Windstar. And this video is not going to be an oil change video, but it's going to be something even better. My Ford Windstar has almost 300,000 miles. You can see there, 292,059 miles. It's a 95. I've owned this since this car has been brand new. And we've done oil changes every 5,000 miles using conventional oil. You've seen all the videos on this car. I take very good care of it. And after 300,000 miles, I'm really curious how this engine's doing. And one method that you could use to test how the engine is doing is to do an oil analysis. So Blackstone Labs was kind enough to send me an oil analysis kit. I'm going to fill this up with oil, we'll send it in, and we'll get the results from the lab to see the condition of the oil, which will tell us the condition of the engine. The last oil change on this vehicle was done at 284,000 miles, and 5W30 was used. So that is an 8,000 mile oil change. While 8,000 miles is a bit long for conventional oil on a 300,000 mile engine, it'll be interesting to see how well the oil held up. So before I go out and take a sample of the oil, I just want to let you know I ran the engine for about 15 minutes by driving the car around, and then we've been sitting here for a few minutes letting it idle, and that just gets all the oil turned up. It also evaporates any water that's in there from condensation, and it gives us a nice sample. So let's see what comes with the kit. You have the bottle that you fill up with the engine oil. You got this oil absorbent paper here so you don't make a mess. You have a Ziploc bag, again, so you don't make a mess when you send your oil sample in. There's some paperwork to fill out. We have a little pamphlet here that gives you information on how to take the oil sample and also gives you a example printout of what your oil sample will look like when you finally get it. And we have an oil change card that you stick on your windshield so you know how many miles you've gone since the last oil change. Let's go get an oil sample. Okay, we're under the engine. The engine's nice and warm. Here's our oil pan drain. We have our container ready to collect the sample. We want to collect the sample as it's flowing out into our oil catch can here. Okay, oil's coming out. Gonna give it a couple seconds to run out. Now I'm gonna go take this, fill it to the top, just like so. Did make a little bit of a mess. Put the lid on, seal it tight, and just clean this off with a paper towel. Now that's sealed, you won't contaminate anything. And I'll clean this off better so when I send it to them, it's nice and clean. But that's it. Oil's coming out. Now I can just finish my oil change. I definitely cannot wait to see what kind of results we get with this 300,000 mile engine. So I've driven this car since it was new. All the family vacations, all the oil changes, all the little fixes here and there. I take care of my vehicles the best I can, as you can tell with all my how-to videos. It's going to be really interesting to see what kind of results we get. Okay, the oil sample's in here. We're going to go send it out, and we're going to get our results. Okay, so we got the results back from Blackstone Labs. I'll put a link in the description to a copy of my results, so if you want a copy to look at, it's in the description. First thing we're going to do, I'll go through the comment section real quick, where they summarize what the results are. And they said they found coolant in the oil, which is shown by potassium and sodium. And they said some of the sodium could be from an oil additive as well. They said coolant could be causing excessive wear. They found a lot of lead, which is from bearings. They also found high copper and iron, which is probably wear at a bearing shaft interface. And there was some aluminum, which is probably from the pistons, and maybe even the head. They also noted that the viscosity was very thick for 5W30. And what I didn't realize was that a quart of STP oil treatment was added, and in the STP oil treatment there is mostly mineral oil, but there's also zinc alkyl dithiophosphate, so that's why we had a high viscosity reading. It was pretty cool that they were able to pick up on that. They also noted that their universal averages are based on 5,200 miles, and that this van went about 8,000 miles before the oil was changed. So now if we go down, we could look. I'm going to go through everything real quickly, and I'm going to focus on the ones that they pointed out that had a high reading. So the first one we'll go over is aluminum. Aluminum could be from pistons, it could be from bearings, it could be from the heads or the block. In this case, the block is iron and the head is aluminum. So they said it's most likely coming from the pistons. I should also mention, the readings are given in parts per million. That basically means that, let's say, for example, aluminum. If you have, like in this case, 8 parts per million, there are 8 parts of aluminum per million parts of oil. It's just a percentage. Additionally, if you look to the right, there's a shaded box, and that's the universal averages. So in general, those numbers are where your oil should be around, and the column to the left of that one are the oil readings from our oil sample. The next element is chromium. and this is a trace element in steel, but it's commonly found in piston rings, and we were actually good here. After that we have iron, and there's iron everywhere inside an engine. It's in cylinders, rotating shafts, valve train, pretty much any steel part in an engine. And our iron readings were pretty high, and that's just from wear and tear. The engine's old, it's the original, 300,000 miles, that's what's going to happen. After that we have copper. Copper comes from any brass or bronze parts. Copper bushings, bearings, oil coolers sometimes have copper in them. We had a high reading of copper, and they said that's probably wear with the bearing shaft interface. Next we have lead. Lead is typically found in bearings, and we have a high reading of lead. They said that that's most likely due to wearing of bearings. Now they're saying the reason why there's so much wear is because the high amount of antifreeze in the oil. Antifreeze doesn't protect moving parts like oil does. So if there's molecules of antifreeze where there should be oil, you can have higher wear in that area. If we go down to tin, tin's found in bearings, bronze parts, and sometimes piston coatings. Next we have molybdenum, and this is an anti-wear additive. Also some new piston rings have this coating on it, and when you break in an engine, it wears off. We're about average on that, so that's probably just from an additive in the engine oil. Next is nickel, and that's a trace element in steel. After that is manganese, another trace element. We have silver, which is another trace element. Titanium, again, trace element. Now potassium is interesting. We had high potassium, and potassium is found in antifreeze. It's an inhibitor in antifreeze. And because of the high reading of potassium and the other wear factors, they're attributing this to coolant being present in the oil. So this is because of the head gasket leak. Now, all head gaskets are going to leak after 300,000 miles. That's just how it is. Now, depending on how much it leaks, that's when it's bad. In this case, we're not getting any froth. We're not seeing anything too detrimental, indicating that we have a big head gasket leak, which we don't. We're not losing any noticeable amount of coolant. But because this test is so sensitive, they're able to pick up these little parts per million. So we do have a high level of potassium. After that we have boron, also found in some antifreeze. That's also a detergent. Silicone, these are found in sealers like RTV, gaskets, and also sometimes it's in antifreeze as an inhibitor. Sodium, we had a high level of sodium. This is found in antifreeze as an inhibitor. Next we have calcium, which is a detergent. Then magnesium, which is a detergent. Then we have phosphorus, which is an anti-wear additive found in engine oils. And then we have zinc, which we had a high level of zinc, and this is an anti-wear additive, and this is from that STP oil treatment. So it's cool to see that the oil analysis actually picked up on this oil treatment, even though it was never mentioned that the oil treatment was used. After zinc, we have barium, and that's another detergent. Okay, so now we're going to go to the bottom. At the bottom here, we have the oil properties. Again, the shaded part is the universal averages, and our readings are to the left. So the first two things we're going to look at for the properties of oil are going to be the viscosity at operating temperature. So you can see here, and also noted in the comments, our viscosity was pretty high, and this is because the STP oil treatment. The oil treatment is meant to be used in vehicles that have oil problems. Maybe it's using too much oil or something, or maybe you're hearing a knock or something. So it's going to have a high viscosity. It's going to increase the viscosity of your oil, and that could be clearly seen here. They also have the flash point here, and the flash point is at what temperature that the oil catches fire. And in our case, we have 415 degrees Fahrenheit, which is above the average, which is good. If you were below the average, it could indicate that you have excess fuel in your oil, and that could be because it's blow-by from the piston rings being worn out. Our fuel percentage, that's just how much fuel is found with the oil, and our reading was pretty good here. Our antifreeze, it says POS, I don't know what that means, but in the comments and also from what we observed, there's antifreeze getting in the oil. We had no water in the oil. Our insolubles were pretty low, which is actually pretty neat because that means that after 8,000 miles, our oil filter was doing its job. Insolubles are just things that would get collected by an oil filter. So that's going through pretty much everything. Hopefully you learned something new. There's a lot of cool information that you can get from this. Obviously, if you could do this when your car is relatively new, and then do an oil sample every 25,000 miles, every 30,000 miles, whatever interval works for you, and then just see over time how your engine is performing, you'll be able to track any wear in certain areas. And you just saw what a 300,000 mile Ford 3.8 liter engine looks like after it's been taken care of for all those 300,000 miles. Unfortunately, we do have wear indicated by the high iron, lead, copper, and aluminum numbers, but that's inevitable with an engine this old with this many miles. You guys always come up with really cool experiments or ideas. I'd like to hear if you guys have any ideas on how I could make a future video using an analysis kit. I'll be testing out the oil in a brand new car, first oil change. I'm sending that oil in, and we'll see what that looks like. It'll be interesting to compare. And if you want to do your own tests, I'll leave a link to the Blackstone Labs webpage. They're super helpful. It's really easy to do. They send you the kit for free. You send it out to them. It's $25 per sample, which isn't bad. You're only going to do this a few times. And you get all this information about your car. And as always, don't forget to give the video a thumbs up, and if you're not a subscriber, hit that subscribe button for more how-to videos.